Hello, everyone. This video is going to cover section 2.2 out of the textbook, which is linear equations. Let's take a look now at these linear equations and work through some of the homework problems in the set. If we take a look, I'll share my screen with you. Hold on while I do that real fast. Okay. Now, if we take a look at problem number 1 out of section 2.2, there's a video attached which you can watch to learn how to solve equations of this type. In this particular problem, we have 9x plus 2 equal to, or negative 9x plus 2. 9x plus 2 equal to 9x plus 5. What we're trying to do in solving an equation is get all the terms that have the variable x in them on one side of the equal sign, and anything that does not have the variable x in it on the opposite side of the equal sign. Now, which side you move things to really doesn't matter, except that we try to avoid negative signs because those lead to lots of careless mistakes. So in looking at this problem, I'm going to choose to move the negative 9x by adding 9x to both sides. Think of the equal sign as sort of a balance between two scales. If we do the same thing to both sides, add weight or subtract weight, then they stay in balance with one another. And that's what we want to try to do. So I'm going to add 9x to the left side of the equal sign, right there with the dot marks, and add 9x to the other side of the equal sign on the opposite side of those dotted marks. Since I've done the same thing on both sides, they're going to stay balanced. It doesn't go out of kilter. And that means that the statement will still be true. Now, negative 9x plus 9x is 0, so I get 2 on the left equal to, well, these are like terms. How do you know they're like terms? Well, like terms have exactly the same variables to the same powers. The only thing that might be different are the constant numbers at the front. That would be the 9 and the 9. And then you add the numbers. So 9 plus 9 gives us 18x. And then the 5 just drops through. It is not a like term with the x term because it doesn't have an x attached. Now we're trying to isolate the x's. And the first thing we did was got the x terms together. Now the 5 doesn't have an x, so we want to move it to the opposite side to get it away from the x terms. So what we're trying to do is isolate our x terms. In the first step, what we were trying to do was combine our x terms. Now we're going to do the opposite of adding 5, which is subtracting 5. Again, remember that the equal sign is where it balances. We have to be sure we do the same thing on both sides of the equal sign. Now, when we do that, I always like to put dotted marks, so I know I've done the same on both sides. Then 2 minus 5 would give us a negative 3 on the left, equal to 18x on the right. We've isolated the term that has x in it. Now we need to isolate x itself. And that means that we need to get rid of the 18. Anything multiplied or divided by the variable will be the last thing to go. So now we're going to take the 18 and we're going to divide both sides by 18. Now, negative 3 does go into 18 6 times. So that leaves us with a negative 1 over 6 on the left equal to x on the right. If you have trouble with reducing, remember that what you're doing is taking 3 and divided by 3 and 18 and dividing by 3, because 3 over 3 is equal to the number 1, which you can always multiply by the number 1. It's one of the things we're always allowed to do. Multiply by 1 or divide by 1 and add 0 or subtract 0. So we are using the property of multiplying or dividing by 1 here. And that gives us x equal negative 1/6. And that's our final answer. Remember on these problems that I want you to number the problem, copy the problem first to be sure that I know which one you're starting with, show your work, and then box up the answer at the end. Let's go ahead and take a look now at the next problem. Well, for fun, I guess we should put in the answer. So this is a -1 divided by 6, and you can use the slash mark for division if I can find it. And then check your answer. Hopefully we get that lovely green. Now we can go on to the next problem. And in this problem, we're going to have to use some of what we'll call the distributive property. So draw a long horizontal line to separate your two problems. And let's start number 2. We have -8 times a quantity in parentheses of x minus 9, then plus 7 equal to 1 times the parentheses x minus 7. Anything that is outside parentheses but does not have a plus or minus between them is being multiplied by what's in the parentheses, but not just one term, however many terms are in there. So I like to draw arrows to show that the -8 gets multiplied by both the x and the -9. Over here, technically the 1 also gets multiplied by each of the things on the inside, although we know that 1 times anything is that thing, so it won't change the x minus 7. Multiplying this out, we get -8x. Note the double negative on -8 times -9 gives us a positive 72. Then we have plus 7 still tagging along, equal to x minus 7. Now here's where a lot of students make a mistake. So I'm going to show you what a lot of students want to do and why it's wrong. A lot of students will want to subtract this 7 that you see right here, the plus 7, with the 72. That's not correct. They're both on the left side of the equation. It balances here. I don't need to subtract 7 to get those two numbers to combine. I need to add them. 72 plus 7 will give me 79. And that leads to -8x plus 79 equal to x minus 7. Remember, our next steps are going to be to get the x terms together. So first we distributed. And then we combine numbers on the same side, combine like terms, or simplify. That's another way of writing that. And then we need to gather or combine x terms. I'm going to look at my x terms and I'm going to choose the smaller one. And because negative numbers are always smaller than positive numbers, that means -8x is smaller than x. I'm going to move the smaller one by adding 8x to both the left side of the equals and the right side of the equals. I can, at the same time, also move the numbers. Since the variable terms are going to end up on the right side of the equation, I can then take the number -7, which does not have an x, and move it to the left side by subtracting 7. Note that I have 8 plus 8x minus 7 on both the left and the right side of the equal sign. So I have kept the equations balanced, which means they're still true and unchanged. The result will be the same answer. Then on the left, -8x plus 8x is 0. 79 minus 7 gives me 72. Oops, I made a mistake. Did you catch it? I did. I looked at that and went, wait a minute, I don't have 7s on both sides. I forgot to do the opposite. Make sure you do the opposite on both sides. To move the -7, we need to add 7. So always double check your work as you're going through. Then we have 79 plus 7, which will give us an 86, equal 9x. This is x, 1x, plus 8x, which is 9x's. Now we need to solve for the x variable itself. And we do that by dividing both sides of the equation by 9. Now, 9 is only divisible by 3, 1, and 9. 86, the two digits add together to give you 14, which tells me that it's not divisible by 3. And since it's not divisible by 3, it has no factors in common with 9 other than the 1. So that is as reduced as it gets. My answer is 86 divided by 9. Let's check it out since we know I made at least one mistake, and let's make sure it's right. Green check, love it. Now let's take a look at the next problem. In this problem, we have rational numbers. These are the ratios of two integers. And that means we have a number in the numerator and a number in the denominator. So we're trying to solve this equation. Now, there are various ways of doing it, but one of the easiest ways of doing it is if you have an equation with an equal sign and something on both sides, you can actually get rid of the fraction part and then solve a simpler problem. Let me show you how to do that. When we're looking at this problem, number 3, we're starting with a negative 2 over 8 minus 9 over 9x equal 5 over 9. Now, one thing that I noticed right away is that I've got a 2 over 8 and a 9 over 9. Now 2 over 8 reduces and becomes 1 over 4 when I divide both the numerator and the denominator by 2, and 2 over 2 is of course 1. That will give me a negative 1 over 4 minus, well, 9 divided by 9 is 1, so that's just 1x or x equal 5 divided by 9. It does help to go ahead and reduce it before you get started. That way you have less work to do at the end of the problem. Now we look at this problem and we divide it into terms. Terms can be separated by a plus sign, a minus for subtraction, and an equal sign or an inequality. In this case, this negative does not separate because it is not a subtraction sign, it's a negative. So we have negative 1/4 as the first term, negative x as the second term separated by the subtraction and the equals, and 5/9 as the third term separated by the equal sign. We look at each one in turn and we find the denominators. The denominators are 4 and understood 1 and 9. Coming over here, we're going to try to find the lowest common denominator. When we're looking for the lowest common denominator, remember what you did in arithmetic. We had a 4, a 1, and a 9. A common denominator is just multiplying the two numbers together. You can also write 4, of course, as 2 times 2, and 9 as 3 times 3. If you break it down into primes, they might have some in common. In this case, they don't, in which case we need all of that. We need 2 2s and 2 3s, or we need 4 times 9, which gives us the lowest common denominator or multiple. And now what we're going to do is we're going to multiply every term on both sides of the equal sign by the lowest common denominator. We're going to put the whole thing into parentheses, and we're going to put the product, which is 36, on the outside. Then we're going to multiply 36 times negative 1 over 4. Remember that you can think of this as 36 over 1 times negative 1 over 4. Then we multiply the 36 by negative x, and that gives us negative 36x. Then we multiply the 36 over 1, if you want to think of it that way, by the 5 over the 9. Remember that we are distributing. This is the distributive property again. So we're distributing this lowest common multiple across every term on both sides of the equal sign. 36 is divisible by 4. We know that because we built it over here, and it leaves behind a 9. So this becomes negative 9. Then we have the minus 36x, which was already in non-fraction form. 36 is divisible by 9, it would leave behind the 4, but that would give us a 4 times 5, which would give us 20. Notice that after we've multiplied by that lowest common multiple, our equation no longer has any fractions in it or rational numbers, the ratio of two integers. Now what we need to do is isolate the x term. The x term is negative 36x. So we're going to move the negative 9 by adding 9 to both sides. This gives me negative 36x equal to 29. Note a very common error that students make. You see this minus here in between? A lot of students will drop that when the number in the front gets moved, and they'll write 36 instead of negative 36. The sign stays, so be careful. The next thing we want to do is divide both sides by negative 36. This will isolate x. Now, negatives and fractions are floaters, and by that I mean you could write it in the numerator, or you could write it in the denominator, and you can also write it out front of the fraction if you prefer. They float between the numerator, denominator, and out front when you have a rational number. So in this case, our solution is negative 29 divided by 36. Let's check our answer and make sure we got it right. It's hard for me to see the numbers on my computer. If you're wondering why it takes so long, I thought it would be a great idea to get a computer that was white, since it would not soak up the sun so much and get hot. But I didn't realize you can't see the letters on the keys. So if you're given a choice, go with a black keyboard. It's much, much better. That's my advice. And we got the green check. Let's look at this next problem here. In this problem, which is number 4, we're going to again have to apply and do the distributive property. So we have 6 times the quantity, 6x minus 6, plus x equal 2x plus 7. First, we need to get rid of the parentheses by distributing. But we only distribute across what's inside parentheses. Again, I find that drawing arrows is the best way to protect yourself from making a careless mistake. This gives me 36x minus 36 plus x equal 2x plus 7. Now I need to combine like terms on the same side of the equation. Again, this is something that a lot of students will make a mistake over. They see the 36x term here and the x term there, and they'll subtract the x to get them together. But that is wrong. The problem is the equal sign is here. You don't need to subtract x to move it, just add them. They're already on the same side. 36x plus another x would be 37x on the left, minus 36, still equal to 2x plus 7. Now we want to combine or gather our x terms. This time I look at the 2 and I see which one is the smaller. They're both positive, 37x and 2x. So I move the smaller one, which is 2x. When you always move the smaller one, you avoid having negatives. When I subtract the minus 2x, I subtract it from both sides of the equal sign. That keeps the equation balanced and still equivalent to the original problem. The 36 does not have an x, so it needs to move. To do the opposite would be to add 36. So I add 36 on both sides, and that leads to 37x minus 2x, which is 35x, equal to 0, 0, and 7 plus 36 would give me 43. The final step is to isolate x, or solve for x is another way to say it. Either way is correct. I'm going to divide both sides by 35. Now 43 is a prime number and does not have any factors other than 1 and 43. So my final answer is going to be 43 divided by 35, which is of course a rational number. And we can check the answer over here. Let's now look at this next problem, which is a slightly different type and something we haven't talked about yet. When we're looking at the next problem, which is number 5, we have the quantity 10 times, in parentheses, p plus 70 equal to 14 times the quantity p plus 50 minus 4p. Now, in order to simplify this, we need to distribute, and that will get rid of the parentheses. So our first step is going to be to distribute. That means 10 times p and 10 times 70. That gives me 10p plus 10 times 70 is 700 equals 14 times p and 14 times 50. You may want to grab your calculator. 14p plus, well, let's see, 14 times 5 would be 70. Since 5 times 10 is 50 and 5 times 4 is 20, that's 70. So another 0 would make it 700. Then I have a minus 4p, which tags along at the end of the right-hand side. The next thing we want to do is combine like terms that are already on the same side. My balance point is here, so I've got a 14p and a minus 4p that can be combined together. This gives me 10p plus 700 equals, well, 14p minus 4p is 10p plus 700. Uh-oh, do you see what's coming? When we try to get the x terms together by subtracting one of these 10p's, they're going to cancel and disappear. Now, this is a special kind of equation, and what we end up with determines what we call it. If all the variable terms disappear and what you're left with is a true statement, we call it an identity. An identity is anything like 2 equal 2 or 5 equal 5, because that's always true. An identity means there are infinitely many solutions. In fact, you can pick any number you want for p and it will still work. Over here, it says write infinitely many if there are infinitely many solutions. So I'm going to try to write that in now. Infinitely many. And then we can check our answers. This again is called an identity when you get something that's true. What if you get something that's false? In other words, all your variable terms disappeared, but you got 5 equals 7 or 42 equal 8. Those are false. Well, that is not going to give you a true statement. So we call that an inconsistent equation. Inconsistent means there's no solution. Nothing you choose for x is going to make that true. And we call that inconsistent. Let's take a look now at problem number 6. In problem number 6, we're going to have to use the distributive property in order to eliminate the parentheses. Okay, so first we distribute. That gives us 3v plus 18 minus the 14, which was not a part of the parentheses, so it does not get distributed over, equal 3v plus 4. I can see what's coming because I have 3v on both sides, which means they're going to cancel. First, let's go ahead and combine these two like numbers here. 18 minus 14, they're already on the left side of the equals, so I can just combine them and say that that's plus 4. In other words, I have another identity. This means that it works no matter what value I choose for x. So there are, again, infinitely many solutions. let's take a look. I'm looking for a particular type. Let's see. Let's take a look at this problem here, which is number 8. We have 7 times the quantity p plus 3 plus another p equal 8 times the quantity p minus 5 plus 66. Okay, first we distribute 7 times the p, 7 times the 3. That gives me 7p plus 21 plus another p that wasn't part of the distribution. And 8 times p and 8 times -5, which is 8p minus 40 plus 66, which was not part of the distribution. Now we're going to combine like terms on each side of the equation and get those together. Like terms means that they're p terms, both p terms, or both number terms. In this case, on the left-hand side, I've got a 7p here and a p here. Combined, that gives me 8p plus a number, which is not a like term, 21. On the right, I only have one p term, so it's going to stay 8p. I do have two numbers, -40 plus 66, which becomes positive 26. Can you see what's about to happen? Yes. When we try to move one of the 8p terms by subtracting it from both sides, we're going to have all of the p terms disappear from the problem. However, what's left behind is false. It is never true that 21 equals 26. Any kind of false statement, even 0 equals 5, leads to the same conclusion. This is an inconsistent equation. Inconsistent in mathematics means there's no solution. So in this box, we're going to type no solutions. Let's take a look now at something that's a little bit different. Now we want to look at slope-intercept form and graphing lines. When we're looking at slope-intercept form, we're talking about lines that go up or lines that come down, or maybe horizontal lines or vertical lines. Most of the time for slope-intercept form, we're talking about slanted lines. So either lines that go uphill or lines that go downhill. And you read a graph from the left side to the right side. So how do you know if something is increasing or decreasing? Again, when you're looking at the graph, if you have a line like this, we would say it is an uphill or positively sloped line, because as you read it from the left side to the right side, you have to go up. So it is a positively sloped line. If it were to go downhill instead, then it would be a negatively sloped line. This refers to the sign of the slope. The slope is a measure of how much the x value changes with respect to the y value, or how much the y value changes with respect to the x value. It's a measure of the rise divided by the run. That's what we call the slope. In this particular equation, it says find the equation of the line that contains a slope of 1/2 and a y-intercept of 0,4. Write the answer in slope-intercept form. Well, what is slope-intercept form? Slope-intercept form looks like this. Y equal mx plus b, where m is equal to the slope of the line. If it is an uphill slope, it's positive. If it's a downhill slope, it's negative. And again, read the graph from the left side to the right side. What is the b? B is the y coordinate of the y-intercept. Lost my n there. of the y-intercept. We've already talked about how to find intercepts. Remember, intercepts are ordered pairs where one of the coordinates is 0. On the y-intercept, x got the ball, so x is 0. So we have some ordered pair, 0, b. This number here becomes this number here. When we're writing it then, to write the equation in slope-intercept form, we simply have to take the slope and multiply it by the variable x. So for number 1, we're going to have y equal 1/2 x, and then we have to add the y coordinate of the y-intercept. On this particular problem, the y-intercept is the ordered pair 0, 4. That means b is equal to 4. So we write plus 4. I almost wrote plus b. And that's it. That's how you're going to write it. Now, to enter it into WebWork, you can either put parentheses around the 1/2, or it should do it in order and then multiply by x. But parentheses are never a bad idea. Or you can always type it as 0.5 or just 0.5. If I can find my point, 0.5 x plus 4. And then you can check your answer. On the next one, we have a question to find the slope between 2 points. When we're looking at the slope, let's think about -2, 5 and 3, -4. I'm going to have to remember that. -2, 5, -2, 5. And we'll label it. And our other point was 3, -4. I'm on Desmos. Oh, I've already forgotten it. 3, -4, is that right? It's too bad you can't be here to tell me. 3, -4, let's double check. -2, 5, 3, -4. If I label that one, then I'm talking about these two ordered pairs. I want to know what the slope of the line that connects the two ordered pairs is. I'm going to take a picture, and then I'm going to paste this into my work. Let's make it a little bit bigger so we can actually see it. Now, when I'm looking at this, the next thing I'm going to do is I'm going to take my index card and I'm going to connect the 2 points with a line. So I take the 2 points and I connect them with a line. And then I want to read the line from the left side to the right side. So from the left to the right, this line goes down. That means I'm expecting the slope to be a negative number. Then we look at the steepness of the line. A 45-degree angle, which by the way is quite steep, has a slope of 1. So anything that is less than 45-degree angle has a slope less than 1, a fraction, and anything steeper than a 45-degree angle has a slope that's steeper than 1, a bigger number than 1. So let's now take a look at this and look at the formula for slope. The formula for slope depends on the change in the y values over the change in the x values. One way of writing change is to use the Greek letter delta. This is sometimes written as delta y over delta x, meaning the change in y over the change in x. It also goes by the abbreviation rise over run, because rise refers to the vertical change and run refers to the horizontal change. The formula for this is going to be y2 minus y1 over x2 minus x1. Or it could be y1 minus y2, but then it needs to be x1 minus x2. What are the ways to mess this up? There are two main ones to mess it up. One, you don't have the change in the y values on top, you have the change in the x values. That will definitely be wrong. Step two, whatever the numbers here are, they should come out of the same ordered pair. these two numbers should also come out of the same ordered pair. Ordered pairs should line up in columns. If they don't, it's going to be wrong. You're going to get the right number, but the wrong sign. Let's take a look now and let's substitute in the values of our points. -2, 5, and 3, -4. The first point we go left 2, up 5. And the second point we go right 3, down 4. I'm going to call y2 to be the 5. I have 5 on top and then a minus for the formula, and the other y coordinate is -4. That gives me a double negative, which becomes a plus. In the denominator, since 5 went first, its matching x coordinate must go first. So I must have -2, minus for the formula, and the other x coordinate is 3. Then I can combine the numbers in the numerator to get 9 over -5. This is a number that is larger than 1, which tells me it's relatively steep, and it's negative, which tells me it's downhill. That fits with what I'm seeing. It's steeper than a 45-degree angle line, and it's downhill. That's my slope. Oops. -9 divided by 5. Note again that the negative is a floater that can go out front, on the bottom, or in the numerator. The next problem we want to take a look at says find the equation of the line that contains the point 1, 9 with a slope of -1/4. Now, it gave us a point 1, 9, but B is not 9. I know that because the x coordinate is not 0. It is the y coordinate of the y-intercept. So it's on the line, but it's not the y-intercept, and it's not the value of B. The slope, however, is a -1/4, so I can put that into my equation. I have y equals mx plus b, which is the slope-intercept form of the line, which is the one we prefer to use 95% of the time in algebra. It's really the slope y-intercept form of the line. I know so far that the slope is a -1/4 times x, but I don't know b. I do, however, know that the point 1, 9 is on the line. That means it must satisfy the line and make a true statement when plugged in. So I'm going to take the point 1, 9 on the line, and I'm going to replace the x coordinate with 1 and the y variable with 9. That gives me 9 equals -1/4 times 1 plus b. Notice that this leaves only b that is unknown, so I can solve for b by isolating it. That means I need to move the -1/4 to the other side by adding 1/4. Now 9 is not written in terms of force, but I can come to the side and write 9/1 times 4/4 to get 36/4. 36/4 plus 1/4 gives me 37/4. That is not the equation of the line. That is the B part of slope-intercept form. So now I write the line y equal -1/4 x plus 37 divided by 4. Let's go ahead and put that into web work. I'm going to type it in parentheses. -1 divided by 4, close parentheses, x plus 37 divided by 4. 37 divided by 4. Did I get that? Nope, I got a 3. I'm telling you, I can't see the numbers on my keyboard. It's like guessing. 37/4. check the answer to make sure it looks okay. They may not like this answer. Why might they not like my answer? Let's check and see. They don't like the answer because I don't have y equals. This should be y equals mx plus b. Let's check it again and see if it likes it the second time. Yes, it's looking for an equation which has to have an equals and something on both sides. Looking for the equation of a line that passes through 2 points means that first we have to find the slope of the line, and then we can use either point to find the value of b and rewrite the equation in slope-intercept form. Let's take a look at this problem here. Our ordered pairs are -5, -1, and -2, -16. When I look at these, I can take either one to be x1 and y1, and I can take either one to be x2 and y2. Then I want to find my slope by taking y2 minus y1 over x2 minus x1. This is going to give me a -16 minus, for the formula, the number is -1, over, if -16 went first, its x coordinate must go next, which is the -2. Minus for the formula, and the other x coordinate is a -5. Be careful that you always use a minus for that formula. This leads to -16 with a double negative, making it +1, divided by -2 with a double negative, which makes it +5. -16 plus 1 is a -15, and -2 plus 5 is a +3. -15 divided by 3 is a -5. This tells me the line is very steep and downhill. When I look at the equation, I can use Desmos in order to be sure that I've got the right point. And I'll show you how to do that in just a second. The next thing we want to do is we want to find the equation of the line. So far, for my y equal mx plus b, I have that y equals -5x plus b. I don't have b because neither of the ordered pairs had 0 for the x coordinate. Take the one with the easier numbers, usually the smaller ones, and use them to replace the x and y variables. In this case, I'm going to use the -5, -1, and I'm going to replace y with -1 and x with -5 to find the value of b. -5 times -5 is a +25 plus b. When I move the 25 by subtracting, this gives me b equal to -26. Then I rewrite my equation as -5x minus 26. Let's take a look at Desmos and see if this jives with what we found. -5x minus 26. We can eliminate our previous ordered pairs by clicking on the x's, and we can type in y equals -5x minus 26. And here's our line. Now we had -5, -1, and if we click on that spot, you'll see that it lights up right there in Desmos. And our other point was, I think, let's see, we can also click on it and drag it up. I think it was at -2 something. Yes, right there, -2, -16. It is on the graph. Notice that the graph is very steep and downhill, with jives with what we got for the slope of -5. Now we want to talk about parallel lines, perpendicular lines, and neither. Let's use the previous problem to demonstrate. On this one, I'm going to turn the line to a different color so it shows up better. Let's make it blue. Now, how do I know that a line is parallel? Parallel lines have the same slope, but different y-intercepts. So any equation that starts with y equal negative 5x, but doesn't have negative 26 as the other y-intercept is going to be parallel. By parallel, we mean they go up and over at the same rate, which means they have the same slope, but they cross the y-axis at different points, making them parallel. They'll never touch and never cross. Now, what would make something perpendicular? Now, you have to be careful with perpendicular. If your axis for the x-axis and for the y-axis are not marked off in the same units, what's perpendicular won't look perpendicular. It'll be skewed. You need a 1-to-1 ratio between the x-axis and the y-axis for perpendicular to look perpendicular. Otherwise, it will skew it. To get something that is perpendicular to a slope of negative 5x, well, we'd need it to be going uphill. And instead of very steep, we'd need something relatively flat. It turns out that the formula is simply the opposite sign and the reciprocal of the previous slope. So we have 1 divided by 5 and then x. Oops, except I put 4. 5 would be better. Where's my 5? Okay, we're back. All right, getting rid of the 4 now. Now I have 1/5 x. Let's come up here. Do you see how it definitely looks like it's perpendicular? Perpendicular means at a right angle. Now again, if I change the scale so that it's not 1-to-1, it won't look perpendicular anymore, but it still will be perpendicular. So in order to find if lines are parallel, we put the lines into slope-intercept form and we compare their slopes. To see if they're perpendicular, we put them into the same slope-intercept form and we compare the slopes. If they're opposite in sign and reciprocals of one another, turned upside down, then we know that they're perpendicular. Let's take a look at the problem again. On this problem, we have 2 pairs of lines, or a pair of lines, y equal 5/4 x plus 6 and y equal 15/12 x minus 7. We want to know, are they parallel, perpendicular, or neither? By neither, they mean they do intersect, just not at a right angle. So those are our choices. They're parallel and they never touch and never cross, or they're perpendicular and they cross at a right angle, or they cross at some other kind of angle, but not at a right angle. We call those parallel, perpendicular, and neither. We're going to look at these 2 lines. Make sure when you look at the lines that it is solved for y by itself and positive. On both of these equations, we want to make sure also that if we have fractions, that we have reduced the fractions. In this case, we have 15/12, and they're both divisible by 3, so they're not reduced. Go ahead and divide the numerator and the denominator by 3, which is the same as dividing by 3/3, or multiplying by 3/3, to rewrite the second one as 5/4x minus 7. Note that they have the same slope, 5/4, but they have different y-intercepts, plus 6 and minus 7. These lines are parallel. In the next line, they're not in slope-intercept form. So what we have to do first is we have to put them in slope-intercept form. We have 4x minus 3 equal 2y. And we have 4y plus 8x equal 12. For the one on the left, I'm going to solve it for y by dividing every term individually by 2. This leads to the following equation in slope-intercept form. Y equal 2x minus 3/2. If it looks weird with the y on the right, you can always turn around and write it on the left, since anything that's equal is equal on both sides. What about the other one? Well, first off, it's not solved for the y term. So the first thing I'm going to do is subtract the 8x from both sides of the equal sign. Now, this is an x term here, the negative 8x, but 12 is a number and they're not alike. So I can't combine them. I simply get 4y equal, put your variable term first, and then your number term. Then divide all the terms by 4. This gives us y equal negative 2x plus 3. Again, to see whether they're parallel or perpendicular, we focus only on the slopes. The slopes are opposite, but they're not reciprocals. To be perpendicular, one line has to be fairly flat and the other has to be pretty steep, or vice versa. So they can't both be relatively steep. If they're both relatively steep, it's not a 90-degree angle. That means that these two lines are not parallel and they're not perpendicular. They're neither. They do cross, but not at a 90-degree angle. The next problem is very similar to the ones we've done before, so I leave it to you to work. And the same is true of 16, but we are going to take a look at 16 because it's got a new type of equation for us. When we're looking at 16, we have the equation x equals 3/5. Let's move over to Desmos and let's see what it looks like when we have an equation that doesn't have both variables in it. Clicking on the x's eliminates what we had before. We have the equation x equal 3 divided by 5. That is a vertical line, which you can see right here. It is kind of weird that x equal gives you a vertical line, but what you're doing is you're actually fixing the horizontal distance. Let's write x equal 4 and see what that does. What it's doing is it's setting the horizontal distance to always be right 4, right 4, right 4, right 4. If you write x equal 4, it means be right 4. So x equal sets the horizontal distance from the y-axis at always the same amount. What do you think y equals is going to do? Let's do y equals 2. When we have y equal 2, instead of a vertical line, we get a horizontal line. It is setting this vertical distance to always be up to, up to, up to. That's what y does. It sets up and down, and it's always up to. So when I'm looking at these two lines, note that every point on x equal 4 has a y or an x coordinate of 4. And every point on the line y equal 2 has a y coordinate of 2. Now let's go back to the problem that we had. We have x equal 3/5, and then we have an equation here. When we look back at Desmos, notice that these vertical and horizontal lines are at right angles to each other. So the only thing that's perpendicular to a vertical line is a horizontal line. The only thing that's perpendicular to x equal is y equal, and vice versa. That means when we're looking at this equation that they must be neither. When we look at this second equation, we can solve it for y to put it in slope-intercept form by subtracting x from both sides of the equal. That gives us y equal negative x minus 5/3. The slope here is a -1. What's the slope here? Well, let's look back at Desmos. When I'm looking at Desmos and I'm on this line, notice that there is what we call rise. It does move up from one point to another, but it doesn't have any run. So there's vertical change, but there's no horizontal change. So coming over here, it has vertical change or rise, but there's no horizontal change. In other words, we're trying to divide by 0. Some number on top divided by 0 on bottom. That is not allowed. In fact, if the 0 is under, it is undefined. X equal has an equation with an undefined slope. All vertical lines have undefined slope. What about horizontal lines? Looking over here again at Desmos, we can see that on the horizontal line, if we go from one point to another, -5 maybe, over here to 0, 2, or over to 4, 2, we can see that the y coordinates are the same, which are both 2, but the x coordinates are different. That means that we'll have 0 divided by some number. That means that the slope of a horizontal line is 0. So the slope of a horizontal line is 0, slope of a vertical line is undefined. Don't use no slope, because what does that mean? When we say no, sometimes we mean 0, sometimes we mean undefined. So don't say that. Say 0 slope for horizontal, undefined for vertical. In this particular problem, this one has undefined slope and this one has slope of -1. To be perpendicular, you have to be able to multiply the two slopes together to get -1. Well, you can't because this is undefined. To be parallel, they have to be the same. That means that this one must be neither. In problem 17, you get 2 pairs of ordered pairs. What you have to do is find the slope of each one individually and then compare them to see if they're parallel, perpendicular, or neither. If they're parallel, they're the same. If they're perpendicular, they multiply to give you a -1. In other words, they have opposite sign and they're reciprocals of one another, turned upside down. What about this problem? This problem is a little bit different from anything we've done before. It says find an equation of the line perpendicular to this line that passes through the point -1, -2. This is kind of a confusing thing to say. So let's put the different pieces on Desmos and talk about what it means. 5y equal x minus 2. Let's do that first. Now we have the line 5y equal x minus 2. Now let's put on the point -1, -2. Now let's take a picture of it so that we can see it while we're working. I'm going to have to create some space here. This was problem number 18. Find the line. And this is what I expect you to do. Perpendicular to 5y equal x minus 2 that passes through -1, -2. Now let's put up our picture. Make it a little larger so we can see what it means. Find the equation of a line that is perpendicular to this line. In other words, don't get this line. This is not the line we want. We want something at a right angle to that. And we want it to go through this point. So hand drawing it, it's going to have to be something like that, where this is a right angle. That's the line we're looking for. Well, it looks like it's steep and downhill. How do we know what the slope of it will be? Well, we need to find the slope of this line first. So we take 5y equal x minus 2, and we solve for the slope. Remember to solve for y to put it in slope-intercept form. This gives me 1/5 x minus 2/5. I'm interested only in the slope of this line. The slope is 1/5. To get the perpendicular slope, we often use an upside down uppercase letter T to show perpendicular. This is a positive line right here with a 1/5 slope, relatively flat, which matches the picture. It's relatively flat, certainly less than 45 degrees. We change the sign and we turn the slope upside down and make it 5/1. That makes it a slope of -5. So the one I want has a slope of -5, and it goes through the point -1, -2. Then I use slope-intercept form to find B. I know that y equals mx plus b, and I know that so far I have y equal -5x plus b. I know -1, -2 is on the line I want, so I replace the y with -2 and the x with -1, and then I solve for b. -5 times -1 is a +5, and then to get b, I subtract the 5 from both sides of the equal sign. That gives me b equals -7. Then I rewrite my line, which you can see here, as y equals -5x minus 7. That's the line I'm looking for. Let's put that onto Desmos and make sure it really looks perpendicular and goes through that point. Y equals -5x minus 7. There it is. It definitely goes through the point, -1, -2, and it definitely does look to be perpendicular to the other line on a 1-to-1 graph. The final problem is an applied problem. When we're looking at this problem, it's an application problem, which is just another way of saying it's a word problem. Let's read through it and see how to solve it. Suppose that the cost of a rental car is $55 for a week plus 25 cents per mile driven. Stop and think. You're going to pay the $55 if you never drive it off the lot. You're paying $55 just to get the keys. Then, if you drive it 4 miles, it costs you another $1, so $56. If you drive 2 miles, that's $2, 25 cents a mile. So that would be $57. What are you doing? You're adding to the $55. So your equation to represent the total weekly cost is y equal 0.25x plus 55. You take the 0.25, the price per mile, and multiply by the number of miles, which is x. That added to the 55 to get the keys will give you the total cost. Our question is, what is the total cost of the car if we travel 60 miles? If we travel 60 miles, we're going to write the equation y equal 0.25x plus 55. They're asking, when x equals 60, what is y? All I need to do is replace x with 60. Y equals, now the 0.25 is also the same as 1/4. If you prefer, you can use fractions instead, which I find to be easier to work with. 60 divided by 4 is 15. There are 15 increments, quarter hours in an hour. So that gives us y equals 15 plus 55, which is equal to $70 total. Notice over here that parts 2 and 3 will not unlock until I get that part correct, which can be a little frustrating sometimes. This is going to be $70. I can check that answer and see if it will unlock the next part. Yes. If the total cost of my rental for 1 week is $73.25, how many miles did I drive? Again, I'm starting back with the original equation, y equal 0.25x plus 55. When we're looking at this, I'm going to write it as 1/4 x plus 55. This time they gave me the total cost, which is the y value. So I replaced the y with the total cost, which is the $73.25. The first thing I need to do is to isolate the x term, 1/4 x, by subtracting 55. This is going to give me, well, I have to borrow, or I guess you don't call it borrowing anymore. What do you call it? Redistributing? I can't remember. At any rate, do whatever it is you've been told to do, and you should end up with 1825. That's what I've got. Equal to 1/4 x. Now, how can I get rid of the 1/4? In order to get rid of the 1/4, right now I can think of it as x divided by 4. Note that 1/4 x is the same as x divided by 4. To undo division, we multiply. So what I need to do is multiply by 4. So 1825 times 4, you can either do long multiplication or you can grab a scientific calculator and do it on the scientific calculator, which gives you 73. I'll show you the long multiplication. 7325, I think. No, just 73. In order to do the multiplication, we take this and we write the following. 18.25 times 4. 4 times 5 gives me 20. So put down the 0, carry the 2. 2 and 4 multiplied is 8, plus 2 is 10. Put down the 0, carry the 1. 4 times 8 is 32, plus 1 is 33. Put down the last 3 and carry the 3. And 4 times 1 is 4, plus 3 is 7. There are 2 decimal places here, so there must be 2 decimal places here. And the answer is 73. Now that I put the 73 into the second spot, let's see if it will unlock the third part. It does. Suppose that you have a maximum of $110 to spend on a car rental. What is the maximum number of miles that you can travel? In other words, your total cost can be 110, but no more. What's the number of miles driven? We're starting back again with the same equation as we've had from the beginning. Y equals 1/4 x plus 55. If I can drive a maximum, or I have a maximum total cost of 110, then I replace that in the y position and I solve for x. The first thing I do is I move the 55 by subtracting it from both sides of the equation. That's going to give me 55 equal to 1/4 x. Then I multiply that by 4 in order to get the total number of miles I can drive. This would give me 4 times 5 ends in a 0, carry my 2. 4 times 5 is 20, plus the 2 is 22. 220 miles. and then you can check your answer. All green. In the next video, we'll be looking at section 2.4, which I believe deals with complex numbers.